Hello friends, so today we're going to discuss another problem from the Combinatorics series I've been working on, and sorry that I uploaded this video a little late, but the 2-3 videos and more videos on this series will be uploaded soon. So we're going to discuss two problems again on Combinatorics series, and they will be solved using simple techniques, but then we'll move towards how to find out NCR, NPR, and I will also upload that video. It will be uploaded in 2-3 hours only, so stay tuned on this channel. So the first question we're going to discuss today is this problem, in which it's a simple problem. It's just a 1300 problem, but this also explains you how to solve such type of problem, because there are a lot of combinatorics problem and you just have to observe some pattern and try to write down some test cases, so you will become more familiar with the problem and then you can solve it out easily. So let's solve this problem first. So you are given a string like s of length n consisting of lowercase alphabets, as you can see. Now your task is to calculate the number of ways to remove exactly one substring from the string in such a way that all the remaining characters are equal. So what does this mean? You have some string, you have to remove some substring, and you have to exactly remove one substring always. You cannot like remove two substring or cannot remove some substring. You have to remove exactly one substring such that the remaining all the alphabets are equal, and you have to find out the number of ways to do that, and you have to find out the number of ways modulo this number, which is a prime number. So that's the whole problem. As you can see in this, we'll draw this as you can see test cases. It's a b a. So as you can see, it's a b. Okay. Yeah. So it's a b a a. So now as you can see, what are different. So in the end, you want that if you remove out some substring, there's only one type of character which is left. If you take out the whole substring, that's also one example, one case. So I'm just taking out the substring which I'm removing, and then you'll see what is the substring which is remaining. So the remaining substring is empty, which is also considered. So the other substring is, as you can see, if I remove like this, then this is only remaining. Then as you can see, I can also do like this. Now I cannot take B also in the other side, which means that I should only take the characters that like they should be continuous. That's one observation you can see. Also I can do like this, which means that I have to remove this part and then A only remove. And as you can see, this is like whole 1, then 2, then 3, then 4. What you can also do is, because the last two characters are same, what you can also do is you can also do like this. You can take out this substring, as you can see, like this, just B, and thus AAA is remaining. You can also remove like this substring AB, so this AA is remaining. Now if you again like take anything, then it will be this substring only. So the answer is 6, as you can see. The total answer is 6 in this case, which is the answer. So I hope you get the question itself, and also drawing out a test case, you might also get some intuition. The intuition is, if I take out some substring from this, let's assume that I also draw out another test case to make it even more clear. If this is like everything is changed, if you take out some middle elements, then if you take out AD, then it will consist of some like different elements. So if you take out some substring from the middle, then you should also ensure that the substring which is left from left and right side, they should be equal. That's, as you can see, if I remove this part, then the whole substring should be same. And also if you take out that, if they are not same, then you have to ensure that one end should be at the first end and the other end should be at this end, such that only D is remaining. And if you can see, like if you extend this logic, you can also see that if it is AA, BB, DD, then what you can do here is, you can either take like this, or you can either take like this, which means that if you remove this only AA is left, or if you remove this, then only like this A is left. Okay, then but if you remove this, then B is also there. So which means that you should only place one end at the extreme, and the other end will be such that you should only remove the part such that this continuous will remain. Because there's only one way, which means that you can remove off some substring such that the continuous left part will remain, or the same can happen on the right side. If you can remove like this, the total number of substring remove is equal to, you have few places, as you can see. I can remove from this position. If this is fixed, then I can move from this position, I can remove from this position, I can remove from this position, and thus the total position is 2. This is actually because you have to remove 2 places only. Like you can remove at this position or this position, because if you remove this position, then like 2 Ds are left. Okay, so I hope you get the point. Also, you can remove this position, but I'll tell you why this is considered again in some other case. So as you can see, there are 2 cases you should remove, and here also 2 cases. So the total answer is 4, because like the total number of some strings or substrings you have to remove such that the total answer remaining is equal to 4, and that's the whole case. But there's also one more case, as you can see. If the 2 extremes are same, which means that like this only, it is like this A, and then B, C, A, then it can also happen that I can remove. What I can do here is I can do the same, putting one end in the left side, also the right side, and then doing the same, which means I can put one I can at this point, one at this point, one at this point. So as you can see, there are 3 points at this point, and the same as you can see, it is on the right side. If you put just one at the left part, then there is one position. So as you can see, this is again counted. That's why I'm not cutting it again. So I just put it here and here. So there are 2 cases, but because the ends are also same, what you can also do in this question is you can put like this, one end here and one end here, or one end here, one end here. So for every position of this, you can have this position also. So which is like, if there is length m of the same characters and m of this characters, then n into m is also added. So that's the whole logic for this problem. I hope you get the intuition. So you have to count out total number of characters which is continuous from the left side, also from the right side. So that will tell you the total number of substrings you can find out. But if the total characters at the ends are same, then you have to also multiply with n into m. Okay, and that's the whole logic. But it will only happen when there are two practice characters. But if the whole string is same, it's a, let's assume, then you will count out the same from left and right side, because you will find out the first continuous string stretch from the left side, and it will be total length of 5. And you will do the same from right side also, which is 5. So which will cause you some problem, because in this, what you can do, if you are guaranteed that there is some character which is also there, so you will also say that, okay, there is some continuous stretch which is from the left side and the other continuous stretch from the right side, and then they will break out some point. So we can apply this logic. But if there is no second element, all the string is same, then you just find out the total number of substrings, or which can be equal to, if there is equal to a, total number of substrings which you can remove is equal to the, because if you can remove any substring, the other string will always be a valid case for our answer. So total number of substrings for any string is equal to n into n plus 1 divided by 2. How I find out this answer? Let's assume that if I put one end at this point, the other end can be at this 1, 2, 3, 4, 5. Now if I put my first end at this point, then the answer 1, 2, 3, 4. So for, as you can see, if I put one end at this point, now I have 5 substrings, possible substrings. If I put my point at this point, then now I have 4 substrings. So then it is 3. So our answer is 5 plus 4 plus 3 is the length of this. So the total summation of this is n into n plus 1 divided by 2, if you know the formula. And that's the whole answer. So you have some test cases. If the length is 1 only, then the answer is just 1. If all the characters are same, then you can apply this formula only. If there is at least, if they are not same, which means that there are at least 2 characters, then it means that they should end at some point. There is some left part, right part, and then you can also check that if the right and left part are same, you can also add n into it. So I hope you get the intuition and the logic for this problem. And then you will just do the, well, because you are doing large multiplication, you have to use this, as you can see, I have already explained how to use modulus. So I have changed my m to this point, and as you can see, this is mod functions. So you will always do the multiplication using this part. And then what you will do, this is the solve function which will find out the answer. Take the input of n, the length of the string and the string itself. If the length is equal to 1, which means that there is only one character, so the answer is 1. If the whole string is same, we have to check. How we can check? We have to check that whether the whole string is same. If the whole string is same, the answer is, we have to find out this value, which is n into n plus 1 divided by 2 mod this m. So because n into n plus 1 divided by 2 can be a very large number, so I have just find out the n into n plus 1 divided by 2, that using this. So I'm just find out, it's a simple way to find out n into n plus 1 divided by 2. And else, if there is, like, if we find out that this answer using this, then it's fine. Else, if we do not find our answer using this, then we ensure that there is some continuous stretch of left part and right part. So if we have to calculate that part, so we calculate that there's always one left part, which is like we have to find out the number of elements which are same from the left part. There's always one element, always. So we will take my left equal to 1, and then starting from 1, not 0 indexing but first indexing, we'll match it with this character with the previous character. If they are same, then we'll keep on adding my left or break out. We'll do the same from right side. So we'll get a continuous stretch of elements from the left and from the right. Okay, now I'll find out my answer. So answer is equal to, if the first character and the last character are same, so what we'll do the multiplication of n into m, which I've told you. So n into m means n is the length of the string from the left side and right is the string length from the right side. So we'll just multiply n into m or left into right. And the other answer is we have to add this answer left part, right part, and we have to also add 1 to it. Now why I'm adding 1 to it? Because see, as you can see in this problem, there is I have added one case, I have not added one case. So as you can see, which I've told you, if I take out this whole, so as you can see, if this is like A, B, C, then if I start from here, I have 3 choices, 1, 2, 3. And if I take from this here part, I have also 3 choices, 1, 2, 3. But I can also take at this part. But if I take this is actually taken as a whole, which means that I'm taking this as a whole. But I can also take this from the left side or also from the right side. So it is double counted. That's why I'm not counting at all. But in the end, I'm adding 1 because this is also answered, which means that this 1 just means that I can also take that case in which I can remove the whole, or take the whole string as a substring, remove it out, and there's no character left. So that's also one more answer left. So that's what I'm adding. So I hope you get the point why I'm taking left and right only. Left and right means that I'm not considering this part also, this part, which is for A, B, C. So I have this position, and this position, but I'm not taking this position also. So I will, and same for the right part, there's 1 position and 2 position, but there is also 1 position. So this position is double counted. So that's what I've taken. I've not counted it at all, but in the end, because we can double count it, you can also, what you can do here is, if you add left plus 1 or right plus 1, then you have to minus 1, or else what you can do, you don't add 1 to it, but you have to add 1 in the end. So that's the answer for this problem. I hope you get the intuition for this problem. You can also draw it out and understand the code. I will put the code in the description. If you like this series, you can hit the like button and spread this series with your friends and your more members, such that they can connect to my channel. And I hope you get value from these videos. If you like these videos, you can hit the subscribe button and like to my channel, and I'll see you in the next one. Keep coding. Bye.